Hello and welcome to this video titled Power over Ethernet. In this video I'm going to cover what is power over Ethernet and why do we need it, what types of things can be powered with this technology, what are some of the benefits of power over Ethernet. These acronyms of PSE and PD will define what they mean. We'll talk about how much power can be sent with power over Ethernet standards. How exactly is the power delivered? Detection and negotiation. How does a power over Ethernet device know that what it's connected to even needs power in the first place? And we'll look at some power over Ethernet monitoring techniques, specifically using a couple of Cisco-specific iOS commands. So let's start with why do we need power over Ethernet? Well, let's take a step back here for a second. What is power over Ethernet? Like the term sounds, it's this idea of running an Ethernet cable to something. And normally we think of an Ethernet cable as having the data go back and forth on that cable. And whatever that thing is that's connected to the Ethernet cable, whether it be a laptop, a PC, an IP phone, would have a separate AC connector to power that device. Well, power over Ethernet says, hey, let's get rid of the AC connector and run power over the same Ethernet cable that's being used to deliver our data. We know that all host devices that connect to a network require some kind of a power. Laptops, PCs, printers, IP phones, Internet of Things devices like your IP cameras and your thermostats and things of that nature. Well, all these things need power, and if they aren't battery driven, they're going to be driven basically by plugging into an AC outlet. And sometimes, due to the placement of where you want this thing to be, finding a close and available AC outlet to run a power cord to this thing isn't feasible or practical. So for this reason, power over Ethernet gives us a practical, useful, alternative way to run power to that device over the same cable that's being used to transmit the data. So essentially, we're going from this, where we have a variety of devices that have two cables. The black cable represents your network data cable that's going to the switch, and then you have the red line here, which represents your AC power that's being used to power the device. We're going from that to this, where the one cable is being used to transmit both things. So I think you can start to see the benefits here of power over Ethernet. Certainly there's a time and cost savings. We have to run less cables around walls, around cabinets, into the ceiling, and so on and so forth. So not only is there less cost because there's less cables we got to deal with purchasing, less AC adapters we have to worry about purchasing, but there's also cost savings from time, right? How long does it take to string one cable up into the wall, up into the ceiling, versus two cables or multiple cables? There's also flexibility. Basically, it boils down to, hey, if you can run an Ethernet cable to that location, you can put a power over Ethernet device at that location. Safety. Power over Ethernet, the delivery of the power is intelligent and designed to protect the network equipment from overload, underpowering, or incorrect installation. So the idea with power over Ethernet is that the device providing the power will not only detect if the device at the other end of the cable needs power, but just how much power is needed so we don't overload or burn out that device. Also from a safety perspective, how often have you been traveling maybe internationally and you used an international power adapter and man, that thing got hot after a while, right? When you touched it to unplug it from the wall, it was pretty toasty. Well, sometimes those things can catch fire. From a power standpoint, hey, if my Ethernet cabling is running the power, it's a lot safer than a mishmash of different power adapters I have based on where this device is going to be. And reliability. The power that's coming is coming from a central and universally compatible source. Going right back to that same analogy I had again. If you have a device, take your pick, an IP camera, or think of some small Internet of Thing device that you're going to connect to the network. Now imagine if that device right now is with you and you are in the United States, well, you're going to have a certain type of AC adapter or jack or connector. You're going to have to plug into that thing to plug it into the wall jack. If you take that same device with you on a plane and you go to Europe or South America or Africa, they have completely different wall jacks with completely different plugs. So there's not going to be any standardization here. It's not going to be reliable. Whereas that same thing, if it's powered via Ethernet, Ethernet is used all across the world. All across the world, they use standard Ethernet cables with RJ45 jacks. So whether that device is being powered in Africa, Europe, or the United States, it's receiving that power on a standard RJ45 connection. Also scalability. Scalability. So if we go back to that previous picture that we just looked at, look at this. So in this situation here on the left, with just those three things, I need 3 power adapters. Or I should say 3 wall jacks that they can plug into. So what if I've got 30 things or 300 things? Where are you going to find all those wall jacks? Now you're going to have strings of long power outlet adapters and things like that. Power bricks. It's not very scalable. Whereas once again, I could have a switch, a 48 port switch, and if all 40 of those ports are capable of supplying power, that's like 48 wall jacks all condensed into one box, which now the cables can be run out 100 meters in any given direction and provide power to whatever's connected to it. All right, so let's talk about a couple of terms here, PSD and PD. If you're going to deal with power over Ethernet, you have to know what these stand for. So power over Ethernet, there are a variety of standards for it. They have evolved over time. So there's 802.3AF, AT, and the latest, which is 802.3BT, which was standardized in mid-2018. And all of these categorize power over Ethernet devices as belonging to one of 2 categories. You've got the power sourcing equipment. So like it sounds, that would be your device that's pushing power down the wire. This would typically be a network switch, which would be your power sourcing equipment, or your PSE. And then you have at the other end of that cable a PD, a powered device, such as your wireless access point, or your IP phone, or your IP camera, or something like that. So PSEs are typically network switches, or they could be power injectors. So for example, here's an example of a couple of power injectors. Now, notice that the power injectors themselves, like these 2 pictures right here, they plug into a wall outlet, don't they? Right? Both of them have plugs that plug into a wall outlet. So when would you use something like that? Well, this would be a case of something where maybe I have a switch that does not provide power over Ethernet. The switch I bought doesn't provide that, or maybe I've maxed it out and I've got a few more ports. So I've got some ports that provide power over Ethernet, but those are all used up. And I have other ports left on that switch that I can plug things into, but those are not powered ports. They don't supply power. Either way, I can't run power down the cable. And what if the other side of the cable is not something that supports, what if we had an Internet of Things device that doesn't plug in, something that relies on power over Ethernet, where the only way you could power that thing is if you plug an Ethernet cable into it. It doesn't even have jacks where you could plug it into a wall or something like that. Well, now I have an incompatibility. I have a powered device without any AC capability, and yet I've got a switch which can't send power to that device. That's where you'd use something like this power injector here. The switch would have an Ethernet cable that runs down to the power injector. Notice that there's 2 ports on here. So one port would accept the cable from the switch. The other port on the power injector would inject power, and that would lead down to the power device. So how much power can you get from power over Ethernet? Well, as I mentioned, the standards have evolved over time. So the original standard, 802.3AF, supplied up to 15.4 watts for the power device. And the latest standards, which is 802.3BT, which also goes by the name of UPoE+, that's Cisco's proprietary way of implementing 802.3BT, can supply up to 90 to 95 watts per power device. Now, one thing to know about these numbers here in this chart under the power budget per device is that those numbers there are how much power is leaving the port on the switch. But not all of that power is going to get down to the power device at the other end. Some of it is going to dissipate as like heat or electrical resistance within the cabling itself. So most of it reaches the power device, but not all of it. So just be aware of that. Also, one thing to mention here, notice how it says power budget. Actually, there's a little bit of misspelling there. It says budge, but it should say power budget per device. You should know what that term power budget means. So when you buy a switch that's a power over Ethernet capable switch, they might say, hey, the power budget of the switch is 540 watts. So what they're talking about is that's the maximum power it can deliver to the power devices. Now that power might be spread out over all the ports in the switch, or depending on what you're powering up, after you use like 10 or 15 ports, maybe your entire power budget is done and you don't have any power left to deliver to some of the other ports. So that you'll hear that term power budget, and that's what that means, the total power available for a power sourcing equipment to send down to its total quantity of powered devices. So how is the power delivered? Well, it really depends on the standard that we're dealing with. We know that Ethernet cables are 8 wires total, so we call this unshielded twisted pair. So here you can see each one of these things here. So like right there, that's a pair of wires. Right? We've got a white wire and a sort of lime green colored wire, and they're twisted together. So this is called a twisted pair. And you can see if that's 2, well, that would be 4, 6, 8. So within this one category 5E cable, there's actually 8 wires in there which are twisted together in pairs. Now, depending on the power over Ethernet standard that you're using, will determine how many of those pairs are actually used to transmit the power. So when you're talking about the earlier standards of 802.3 AF and 802.3 AT, those utilized 2 of the pairs. So actually, 2 of the pairs were used just for data, 2 other pairs were used for the power. So that one cable within it separated it out. Some wires were used just to deliver the power, other wires were used just to deliver the data. Then once they came up with the newer standards of like 802.3 BT, which Cisco does in their own sort of way called Universal Power over Ethernet, now we're talking about using all the pairs, all 8 wires to carry both data and power. And it gets kind of complicated as to how it actually does that at the physical level, but just know it works. It is capable of doing that. So the last thing I want to talk about here is when something plugs into an Ethernet switch that's capable of delivering power over Ethernet, that Ethernet switch needs to know, is the thing that just plugged into me something that needs my power? Like maybe what plugged into me is a laptop that has its own separate AC connector. I don't need to send power to that device. It's being powered separately. Or maybe what just plugged into me is an IP phone, and that thing needs me to power it up. Well, how does it know? And we're going to talk at a real high level here just for a minute on how that detection process takes place. So when power over Ethernet is enabled on a port, here's what happens. First of all, we need to know, are we connected to a power device or not? And if so, how much power does it need? Because remember, we can go from 15.4 watts all the way up to like 90 watts, depending on which standard we're dealing with. So here's a summary of the initial steps we're going to go through. Number 1, the power sourcing equipment, i.e. network switch, will output a small amount of power to detect if there's any resistance. So power is going to go out and it's going to see if any of that power comes back on a separate cable or a separate wire. Now, if we're talking about a powered device, like an IP phone or a surveillance camera that's an IP surveillance camera that needs power over Ethernet, that device will have on the wire that's receiving the power special resistors in it that will, so when it sort of loops the power back to the power sourcing equipment, it'll change it in a little way, like a little bit less power will be looped back than what came down from the switch. That's how the switch will know, okay, I'm connected to a powered device. Because if the device I was connected to was not a powered device, like a laptop, the amount of electrical energy I sent down, which is very, very, very tiny, it's not enough to hurt the NIC card or hurt the device at all, that amount that I sent down would be reflected back to me in full. It wouldn't be changed. And so I'd know, okay, there's no resistor down there, there's nothing that's blocking it or reducing it, So therefore, whatever that device is not a powered device. But the amount of electrical energy I get back is a little bit less than what I sent down, and there's a certain ratio. It can't just be some random amount less. Power over Ethernet says, okay, it's got to fall within this threshold here. If the amount you got back is within this threshold, and those details are more than we need to know for this video, but if it's within this threshold, that is a powered device. Okay, so now what happens is the power sourcing equipment will start sending a little bit of power, just enough to sort of like bring that device up into like a bare bones booting state. And so we're going to go back and forth with this, with sending a little bit more power, sensing the resistance. Oh, now the resistance is this much. That tells me the power device can handle even more. And it'll keep going back and forth. And so by using this electrical energy and resistance values and thresholds, we'll get to the point where we know we've reached our limit. Now that device is good to go. And so now the PSE knows just how much power to deliver. Now, in addition to that, so this is all part of the Power over Ethernet standard. Whether you're talking about 802.3 AF or AT, it's all based on resistance levels and how much power we got back. Was there any resistance? That's how, in the specifications, you can tell what type of device you're connected to and how much maximum power it can take. But above and beyond that, a lot of devices also implement either the Cisco Discovery Protocol, if we're talking about Cisco devices, or the Link Layer Discovery Protocol, LLDP, for non-Cisco devices. And even Cisco devices support LLDP. Well, if I, by using these resistance levels and everything, if I can power up that device to the point where it can now start sending me CDP messages or LLDP messages, that device, that power device, can now tell me, the power sourcing equipment, even more information about itself. For example, it might tell me, hey, here's the range of power. I would prefer you give me this maximum amount, but I can actually operate with this minimal route right here. And we can get that information. We can now get information about like what type of device is it. So we can send it other information above and beyond just basic power requirements. So let's just finish off here by saying, how would we monitor this on like Cisco devices? So here we have the output of show CDP neighbor detail. And this is on a switch. And we can see here down below, it says power drawn 10.25 watts. So this represents the maximum required power for this. This is an IP phone. Okay, so we can see this is it mentions up above in platform that this is a Cisco IP phone. And the Cisco IP phone has said that the maximum power we'll ever need is 10.25 watts or 10,250 milliwatts. Notice down here under power request levels, this says this is the IP phone's way of saying, hey, I would prefer to operate at 10.25 watts. However, I am capable of operating at 6.3 watts with a reduced screen brightness. So this particular phone has reduced screen brightness, and if it's on that setting, it doesn't need to draw nearly as much power. So you can see from CDP Neighbor that we've gotten that information from the phone via CDP messages. We can also do show power inline on the switch. This shows us a lot of useful information. For example, we can see here that module 1, its power budget, the maximum amount of power it has available in that module is 420 watts. Very little of that has been used. Right now, only 22.2 watts of that has been used, with most of it still remaining for other ports in that module. And we can see down here below that gigabit 101 is connected to a 7960 phone, which is currently operating under minimal power with reduced screen brightness. It's operating at 6.3 watts. And it says on the far right column, it's capable of a maximum of 15.4 watts. So that concludes this video on our introduction to Power over Ethernet. Thank you for watching.